Good day, ladies and gentlemen. You are welcome to another section of Easy Learning, Apex Easy Learning. I'm by name PSAM. Last class, we started with this heat and temperature, and we're going to continue from there today. Last class, we stopped on the measurement of temperature, how we use thermometer to measure the temperature. We are still going to continue with the measurement of the temperature. Now, in measuring with a thermometer, the thermometer has two reference points, or we call it fixed point, the upper fixed point and the lower fixed point. The upper fixed point is the temperature of the steam from pure water boiling at standard atmospheric pressure of 1 atm, that is 760 millimeter mercury, and it is 100 degrees Celsius. Then we have the lower fixed point, which is the temperature of pure melting ice block at standard temperature, standard atmospheric pressure, which is the same thing as the 1 atm. Then we have the interval between the upper fixed point and the lower fixed point. We call it fundamental interval. Is the difference between the upper fixed point and the lower fixed point of a thermometer. The calibrations or the fundamental interval of a thermometer depend on the temperature scale choosing. We have three different temperature scales according to this class. We have the Celsius scale, we have the Fahrenheit scale, and we have the Kelvin scale. The Celsius scale, the upper fixed point of the Celsius scale, the first bar here in this picture here that you can see here is the Celsius scale, which is 100 degrees Celsius as the upper, and the lower is 0 degree Celsius. So the line ABC shows the Celsius scale. The line DEF shows the Fahrenheit scale, that is degree Fahrenheit. The upper fixed point is 212 degrees Celsius. The lower fixed point is 32 degrees Celsius. While the Kelvin scale, which is the lower, is 273 Kelvin, while the upper is 373 Kelvin. Now, let's look at how we can convert one temperature scale to another. Let's assume we have a temperature scale or a thermometer which reads an arbitrary temperature scale of 8 degrees Celsius as steam point, C degrees Celsius as ice point, and we are to compare it with the Celsius scale, which is reads X degrees Celsius, and we are comparing the points on that arbitrary scales B degree. Let's quickly look at how we can convert it. Okay, comparing it A degrees Celsius at steam point. So when you look at it, A is at steam point, which is 100 degrees Celsius. Then the C degrees Celsius at ice point, which is 0 degrees Celsius. Then we are comparing a value on B degree Celsius to X degree Celsius. The B degree to S degree Celsius is what we want to do. So in comparing this, we are going to have this is going to simply be 100 minus the lower fixed point, which is 0, all over X minus 0. You follow the same process here. A minus the lower C all over B minus C. So this is what we are going to have as the conversion. This is what we are going to have as the conversion. Okay, let's look at this question. The question one there, room temperature is generally defined in physics to be 25 degrees Celsius. What is room temperature in degree Fahrenheit and in Kelvin? So let's quickly look at that. The room temperature is 25 degrees Celsius. So if we are to compare it and find it in degree Fahrenheit and Kelvin, meaning we compare Celsius scale, which is 100 degrees Celsius, 0 at the lower, then we have 25 degree. Then also we have the Fahrenheit scale. So the Fahrenheit scale here, you see the upper is 212 and 32 is the lower when you look at the one that we've explained before. So if we are to calculate this, this is going to be 100 minus 0 from the explanation we did earlier, 25 minus 0 now equal to 212 minus 32 all over x minus 32. So this 100 minus 0 will give us 100. 25 minus 0 will give us 25. 25 equals to 212 minus 32 will give us, let's press calculate. That is 180 all over x minus 32 will be x minus 32. So if you cross multiply 100 times x, let me create this, that is 100x. 100 times 32 will give us 3200. This can now be equal to, this equal to 180 times 25. That is 4,500. So we collect like times, we'll be having 100x equal to 4,500 plus 3,200. Then we'll be having 100x equals to 7,700. 100x is here. 100x equals to this. So we divide both by 100, we divide both sides by 100. 100 cancel 100, it cancel 20 here, meaning x will be equals to 77 degree Fahrenheit. But we have a shorter way of answering this in case we have jump question. If we have jump questions, you can easily use a very simple method, simply by just saying your degrees Celsius times 1.8, then plus 32 will give us in degree Fahrenheit. So we have 25 degrees Celsius there. So 25 times 1.8 then plus 32. If you press your calculator, to give us 77 degree Fahrenheit. So in case you come across JAMB question, you can use this simple shortcut. So if we are to compare it with Kelvin temperature scale, we'll be having 100 as this, then 0 degrees as the lower. Then don't forget that the upper of the Kelvin is 373, then the lower is 273. So if you subtract it the way we did it, 100 minus 0, 25 minus 0, 373 minus 273, K minus 273, like the way we have done the rest. Then it will give us 100 over 25. Then 373 minus 273 will also give us 100. Then if you look at it, this 100 can cancel 100. This 100 here can cancel 100, and you can have 1 over 25. 1 over 25 equals to 1 over K minus 273. And if you cross multiply, you will be having K minus 273 equals to 25. So if you collect like times, you'll be having K equals to 25 plus 273. And this will give us 298 Kelvin. So very easy to do. In case you are to answer in JAMB question, it's a very simple conversions of Kelvin is simply by adding degrees Celsius plus 273. So it's a very simple thing. So 25 plus 273 will give us 298 Kelvin. So we don't need that long calculations in case you are dealing with objective questions. So let's look at the second questions there. The second question says a thermometer with an arbitrary scale S of equal divisions register minus 30 degree at the ice point and plus 90 degree at the steam point. Calculate the Celsius temperature corresponding to 60 degrees Celsius. This is the past JAMB question. So let's look at how we solve this question. So from there we have these calculations. You can see it. The upper fixed point of that is 90 degree S, minus 30 degree S is the lower. Then we have to compare it to 60 degree S. So we compare with 100, the degree Celsius scale. So when you look at it, the solving is like this. You look at it, at the end of the day, we get 75 degree Celsius. You can punch your calculator to follow this up. This is plus or minus. This is minus times minus give us plus. That is why we have 120, and this is how we have 90 degree. So in case you have any questions to ask, you can please contact us on our page. We'll be glad to attend to you. I'm by name Pisam. Thanks for watching. Goodbye.